Hi, my name is Tom Mulcahy. I'm a software engineer at Block. Instead of building code into an APK, I thought it'd be fun if I could instead just get code to run within an existing app process without modifying the APK at all. I couldn't find any tool to do this, so I built my own. I call it Stoic. I didn't do this purely on a whim. There are some practical use cases, like creating tools. I'll demo with radiography. Has anybody here used radiography before? It's a tool my colleague Zach created. I like adding radiography's output to crash reports so I can see what was happening at the time of a crash. Then when I want to reproduce the crash locally, I try to get the UI into the same state. So I wanted to have a way to print the radiography view hierarchy representation on demand. Normally, I'd probably have to create a content provider or a broadcast receiver in every app that I work on. But with Stoic, I can create just one plugin that will work with any app without modifying the APK at all. So I'll demo this. So what I'll do is I'll create a new radiography plugin for Stoic. And I will add a dependency on radiography. Give myself some more room here. And sync Gradle. And now this is just some boilerplate inside my Stoic function to show how you can use Stoic. In the case of radiography, it's accessing the UI layout, so I need to run it on the main thread. So to produce the output, I'll just call radiography.scan. And let's try it out. To run it, I have to give the name of my process and the name of the plugin I want to run. And you can see it produced the radiography view layout just like I wanted. I should mention the app that I'm demoing this on, there's nothing special about it. It doesn't include any Stoic code or dependencies. And I'm also using just a normal Android 15 build running on a Pixel 6 Pro. There's no root involved, so you can probably use this in your day-to-day development today. So I ran code inside an app without modifying its APK. I think that's pretty cool. But what else can we do with this? Let's say I'm investigating the memory usage of my app. And I see that the native heap is quite large. It's formatted kind of poorly here, but this is in kilobytes. It's 153 megabytes. So I know that on modern Android, one of the things that lives in the native heap is bitmaps. And in my experience, they're responsible for a lot of memory problems, like the SEV I was just investigating last week. So without Stoic, I suppose I could capture a heap dump, and that would show me the sizes of the bitmaps, but I wouldn't have access to the bitmap data because the bitmap itself lives on the native heap. So I'll show you what I can do with Stoic. I'll create a new Stoic plugin. And I'll just get rid of this boilerplate here. And Stoic provides some advanced debugging APIs, so I can get a list of the bitmaps in my heap. I can get a list of any class that I'm interested in. And I'll print out a bitmap count. And I'll also iterate through the bitmaps and print out some stats about each one. And also the total allocation byte count. And let's try running that. Okay, so there's only one bitmap, but it is massive. This is almost 139 megabytes. What is that thing? So because I'm running in the process with the bitmap, I can call an API on the bitmap to write it to a JPEG. And I'll just pass in 75 for the quality, and I'll write it to Stoic standard out. Now these print lines are also printing to standard out, so I'm going to have to get rid of those, or else I'd end up with a corrupted JPEG. Now I'll rerun my plugin. This time I'll redirect standard out to a JPEG file, and then I'll open that JPEG. And let's see what this thing is. Oh, right. It's the I should buy a boat cat. This is one of my favorite memes, but maybe I could downsize it a bit. For my final demo, I want to take a look at the source of my example app. I've got this getStringForIndex function, and the way that's used is I have this recycler view, and getStringForIndex returns the string to show at each position in the recycler view. So I'd like to trace to see exactly when this is called, and I can do that with a Android Studio breakpoint. I just unclick suspend and check the breakpoint hit message. Now, when I attach a debugger, and I'll give some more space here so we can see what's going on. And when I scroll, I get these breakpoint reached logs. But what I notice is that scrolling is a lot slower. The app is almost unresponsive. To more clearly show what's going on, I've been logging how long each getStringForIndex takes. And it's taking a double-digit number of milliseconds. But that function is doing almost nothing. So this is basically pure debugger overhead. And if I detach the debugger and scroll some more, you'll see that normally this takes only single-digit microseconds. So that's like almost useless, I'd say. When the timing of something changes so drastically, I'm likely to end up with a Heisenbug where the problem I'm trying to debug disappears when I have the debugger attached. So I'll show you what I can do with Stoic. For this one, I built my Stoic plugin in the same project so I'd have access to the symbols. Same thing here, I'll just get rid of this boilerplate. And I'll import the main activity getStringForIndex. And Stoic provides this for each invocation API, so I can get a callback each time getStringForIndex is invoked. And normally this would exit immediately, so I'll read from standard in to stop that. And let's try running that. and I'll just show the screen here. And when I scroll, now I'm getting these callbacks, and scrolling is still quite smooth. And looking at how long each takes, it's taking less than a millisecond. So that's not nothing, but it's 2 orders of magnitude better than the Android Studio approach. So I'll take that. So I hope that explains why I built Stoic. The next question people sometimes have is, but how? How is this possible? I'll start with a high-level overview. I attach to the target process, start a server inside it, connect to it from my laptop, send the compiled code to the server, and run the compiled code within the server. Now I'll walk through that in more detail. On the left is my laptop. On the right is my Android phone. I push some files to my Android phone, and one of those files is an Android script, which I'll now run via ADB shell. And at this point, we're running code inside the phone, so let's zoom in on that. On the left is the shell process where my script is running, and on the right is the target app. I want to copy the remaining files over to the application private directory, but permissions block a straight copy, so I have to pipe them through run as. This command at the top is a bit cryptic, but what's happening is I'm reading the source file and writing it to standard out, and then in a separate process running as the target app user, I'm reading the standard in and writing to the destination file within the application private directory. So remember when I said I attached to the target process? That's what I'm doing here. One of the files I copied over is the Stoic JVMTI agent. JVMTI is the Java Virtual Machine Tool Interface. It's a low-level debugging API for Java, available on Android since Oreo. I use AM, that's the Activity Manager command line interface, to attach it to the target process. And at this point, we're running inside the target process. Let's zoom in on that. The remaining file is the server dexjar. Remember when I said I'd start a server inside the target process? That's what this server dexjar is for. The JVMTI code is written in C++, but I can use JNI, that's Java Native Interface, to create a class loader for the server dexjar. Load the server class and call its entry point. And at this point, we're in Java land, so let's zoom in on that. I'll create a Unix domain socket server, and then back on my laptop, I'll ask ADB to forward the socket from Android. And then connect to the server, and send a load plugin request, which includes the compiled code from my plugin. So back on the server on Android, I'll create a class loader for the plugin, load the plugin class, and call its entry point, and multiplex the I/O streams across the connection. And it seems appropriate that there are 13 steps because this feels like witchcraft. So that's the end of my lightning talk. If you'd like to try out Stoic, you can install it with Homebrew, and I'll stick around for questions. Thank you.